good morning, good evening, or good afternoon, depending on where you are in this world, and welcome to today's Security Boulevard webinar. I'm your moderator, Charlene O'Hanlon, and I welcome you to the event. Before we get started, I do have a few housekeeping items I need to go over. First of all, today's webinar is being recorded, so if you miss any or all of the event, you'll be receiving a link in an email post-event that will take you to the webinar on demand. And we are taking questions from the audience. So if you have a question for our panelists at any time during the event, just use your GoToWebinar control panel, submit your questions, and we'll take a few minutes at the end of the webinar to go over those questions. Okay, with that, we'll go ahead and get started with today's webinar, Security at the Speed of Software Development, a lean, agile transformation approach to achieving a DevSecOps culture. Our speaker today is Larry Maccherone, who's an industry thought leader on DevSecOps. And he is going to be joined a little bit later on in the webinar by Gabrielle Avner, who is head of content at WhiteSource. Larry, thank you very much for joining me today.
Thanks, Charlene, for having me. So very pleased to be here.
Excellent, excellent. Well, I'm going to go ahead and just turn things over to you and let you do your thing.
Great. So I wanted to start off with something maybe a little bit that'll be a little bit memorable for you. A sharp that I think is a little funny, but it's funny because it's partially true. The phrase DevSecOps is a wave, is a marketing wave. There is market research now that says that DevSecOps is going to grow at 30+% per year for the next 7-8 years. So anyone who follows that stuff says we have to reposition our existing offering to look like it's DevSecOps. The problem is that a lot of that repositioning is just marketing, and there's no attempt to really make the traditional security tool or concept or whatever actually fit well with teams that are actually trying to get the true benefit out of DevOps. And so I think it's kind of a cute way to sort of think about that. I'm going to talk about a way that I think you need to be thinking about DevOps and DevSecOps, and really will highlight and come back to this theme at the end about how a lot of things that are on the market today don't really fit very well with this philosophy, at least my version of it. A little bit about my background before we get into the meat of this. I graduated from Virginia Tech with an electrical and computer engineering degree. I started my first business while I was an undergrad at Tech, grew it to 80 employees, $20 million a year in sales. Our biggest client was GE Power Generation turbines. And we wrote the software that controlled the power generators that feed the power grid, not only in the United States, but in throughout the world. GE had the largest market share of all power generation turbine controls. And imagine if the bad guys found a vulnerability in the software we were writing and could bring down the world's power grid. That would be tragic. And so we got really good at writing software in a highly secure way. I created a whole framework around how to do this, and we spun out a company called Qualtrics to sort of market a part of that framework. In the course of doing that, I got noticed by the folks at Carnegie Mellon who were sort of picking up on this idea, software engineering institutes located at Carnegie Mellon. They were picking up on this idea of security being something that developers should be playing a more active role in rather than the security specialist. And so they asked me to come to Carnegie Mellon to lead the SciLab there. And while I was there, I met with a woman named Nupur Davis, who's now the Chief Information Security Officer at Comcast. So we'll come back to her in a little bit. And another gentleman by the name of Gary McGraw, who was not at Carnegie Mellon at the time. He actually was just growing a small consulting firm around security called Cigital. And Nupur and myself and Gary got together and we launched this website essentially called Build Security In. And we got funding from the Department of Homeland Security. It's still alive today and still has basically the same structure that we had a decade ago. And that effort was somewhat successful, but it wasn't as successful as we wanted to, because a lot of the security risk is in operations. And the developers at that time were in a mode of throwing their product over the wall to ops, and they had a bigger impact now. Now with the DevOps movement, those two things are coming closer together, and we feel it's sort of a new opportunity to reintroduce the concepts of security in a way that fits with DevOps. And so this talk is essentially a reintroduction of a lot of those ideas that are essentially a decade old. A little bit more about my background before we jump in. I left Carnegie Mellon in 2009 because I gave a talk at the Agile conference on basically the correlation of practices with outcomes like security. And Rally said, our customers are asking for that. Come work for us. And I went there because Rally has a database of 10,000 teams worth of data at the time. And they offered to allow me to crawl through that data in an anonymized form and actually vet out the theories that I had that certain practices led to better, performance in productivity, predictability, quality, responsiveness, security, et cetera. So I published the largest ever study correlating practices with performance while at Rally. And that's how I'm mostly known in the industry. That's where I sort of have done most of my public talks and my conference talks until recently, till like the last couple of years when I pivoted back to security mostly. I'm still an active developer. I have a dozen or so open source projects that I manage. I think it's really important to be an active developer and to have developer cred when you go to meet with developers. So when I tell them that this node local storage product is mine, it gets over 200,000 downloads a month now. That product is frequently used by the developers who I'm speaking with. And so I have instant cred with those folks. And I think that's really important throughout this. Now I work at Comcast. I'm the director for DevSecOps transformation at Comcast, and working again with Newport Davis, who helped us launch the Build Security Initiative a decade ago. So it all comes around again. So the problem is that the old bolt-on way of thinking about security just won't scale. There's the rate of change of software is accelerating, and even if it weren't accelerating, if it were just at the current pace, security specialists groups can't keep up with it with a gating mentality. So we have to move it to the left is sort of the phrase. I don't really like that phrase too much because I don't think it really gets at the meat of what you're doing. But we have to get development teams to become primarily involved in the concept of security and securing the products that they're building, pushing into production. And so that's basically the problem statement and the general idea of what we're trying to do. I take it a step further. I actually think there has to be sort of an ownership element to this. And so my definition of DevOps is empowered engineering teams taking ownership of how their product performs in production. If you add the sec in the middle, which is, admittedly, a little bit of marketing, you're basically just adding that emphasis for a particular context of a conversation, and then you can tack on including security at the end. But at its base, it's essentially DevOps. And I think DevOps is empowered engineering teams taking ownership, not just of the writing of the software, but also how it performs in production. So I have this DevOps continuum. A lot of folks use this infinity loop model for DevOps, so I'm not the first person to do this, and I probably won't be the last. And this is my general purpose DevOps continuum. I use this when I'm talking about DevOps or DevSecOps in a lot of variety of ways, usually by grafting over an overlay of something over this image. We're going to graft over it right now a list of practices, and later in the talk, I'll graft over it a tools landscape of how the tools sort of relate to these phases of development. And in the interest of time, I'm not actually going to walk through and talk about every practice. There's a list of about 30 practices, and we'll drill down to a few of them as we go through the rest of the talk. But there's a couple that I'd like to, or at least one that I'd like to highlight now, and that is this analyze and learn phase. And this analyze and learn step in the continuum I think this is really critical because the traditional model of gating products through a security review into production is sort of flawed. I encourage teams to get to the point where they push to production when their product has run the automated gauntlet successfully. Maybe there's a manual code review of the changes since the last time that's done by a member of the team as well. But the gauntlet is run, might include that code review. And you will push to production without waiting for a professional or independent security assessment being done. Now, of course, you should still keep doing these independent security assessments, but they're done out of band. They're done even on the product that's already been shipped into production. And so when you get rid of the gating function of this assessment and you switch it to an out-of-band process, then its value becomes one of learning. So I have this concept called the defect, incident, or vulnerability three-step. And basically the idea is there are three things that you should do when you find a defect or they have an incident or your security assessment team comes back with a list of vulnerabilities. Of course, you should fix those particular vulnerabilities, but you shouldn't stop there. You should say, what's the pattern that matches this vulnerability? How did this happen? How does this manifest itself? And you should look for other places, both in your current product, the one that went through the assessment, and other products you're responsible for. And you should find and fix all of those examples of it. So that's step 2 in the 3-step. Step 3 is that you should look for a way to change something, change your technology, change your testing suite, change your training, something that will prevent that particular problem from ever occurring again. And sort of the most extreme example of this I could have is that if buffer overflows are sort of what's killing you, this goes back a few years to when everything was mostly C, C++ in production, is switching to Java eliminates the possibility of a lot of buffer overrun type vulnerability. And so that's a dramatic technology change to prevent a whole class of very dangerous vulnerabilities from ever occurring. Now that's a pretty dramatic change. Most of the time you don't need to make that dramatic of a change, or you can't make that dramatic of a change. But you should think about and try to come up with a preventive measure that will be effective going forward. So this is the slide with the version of the slide with all of the things turned on. I have a printout of this hanging on my wall, and the number of other folks do as well. So just sort of summarize this. And this is the so-called, quote, framework that WhiteSource, grabbed a hold of, and they started sort of talking about it in their own work, and that's how we got connected with WhiteSource and led us to them sponsoring this event here. But that's a lot of stuff, and I said we wanted to get engineering teams to take ownership of how their product performance in production, including security, was the goal. How do we get engineering teams to actually adopt that? So just coming up with a list of things is easy. Getting the people to actually adapt and change is the hard part. And that's really where the magic of this framework comes in. And so I'm going to talk about my 3-part framework for adopting new practices into development organizations. Now, this framework is sort of the tailored version of the framework for DevSecOps, but I've used this framework before. I spent, when I was at Rally, I published the largest ever study correlating practices to performance. And out of that, I basically came up with a list of practices that were highly conducive to high performance. And I wanted to sort of get them out there. So I developed this framework that would help development teams sort of move towards that list of practices. But these were Agile teams. So this was an Agile transformation framework at first. And then I started working with teams that wanted to become more DevOps. And so I developed a list of practices. Didn't have as much scientific backing for which practices were most effective, though. But I still use the same transformation framework. And I've used this at large companies like Ford Motor Company and USAA to accomplish these large Agile or Lean or DevOps transformations. In this case, I'm using it at Comcast to accomplish a DevSecOps transformation. It's still the same general framework. The first step in that framework is you have to have credibility, you have to have trust, you have to win the hearts and minds of developers. And this is hard for security specialist groups to do. The typical relationship between the security group at large organizations in particular and the development teams is one of at the very least a little bit of tension, and sometimes it's downright uncomfortable, the relationship, and there's a lack of trust between the two groups, and you're never going to win the hearts and minds of developers with that lack of trust. So I have a number of sort of tools that I give to security specialist groups that will help them win the hearts and minds of developers. One of those tools is this list of principles that I've labeled the DevSecOps Manifesto. There's actually a couple of other versions of the DevSecOps Manifesto out there. I like those as well. This happens to be the one that I think sort of fits with my particular approach the best, so I'm not dissing those alternatives or even recommending mine over theirs in a competitive way, but this is my version of the DevSecOps Manifesto. It's formulated in the form that a lot of development teams will recognize, something more than something else. That's exactly the way that the Agile Manifesto is formulated. It doesn't mean that the thing after the more than is not valuable. It just means that we're emphasizing or we're valuing more, at least in this context, the thing before the more than. And so the first bullet up there now, build security in more than bolted on, is not a statement that we're not going to have any bolt-on security. I mean, we still have network firewalls, and we still have the ability to look at network traffic and try to identify bad guys, and those are very bolt-on type activities and will stay bolt-on activities. I'm not recommending we stop doing that, but we want to put the emphasis back towards building security in from the get-go. The next bullet is rely on empower engineering teams more than security specialists. We already talked about this a little bit. The idea here is that you will never get there with just security specialists. We have to have the engineering team involved. And then implement features securely more than security features. So if you go to talk to a developer about security, there's a few things that pop into their head. They think about encryption. They think about authentication. They think about authorization. And that's in their mind what security is. And if you just focus on those things, those security features, that's sort of like taking a bank vault door, 3-foot thick steel with a really hard to pick lock, and bolting it on any old room in any old building. The bad guys are going to ignore the highly, evolved and protected security feature of the bank vault door, and they're going to just bust through the walls of the vault. And the equivalent to that in our software is the features in our product that are just there to provide the functionality that the product has. Any input to the product is a potential avenue for an attacker. And so we have to actually be implementing those features securely, not just thinking about security features when we mention the word security. We already talked about this, rely on continuous learning more than end-of-phase gates. And then build on culture change more than policy enforcement. When we first launched this initiative at Comcast, our CISO, Nooper, was part of a group that organized this sort of offsite, this day-long offsite. And the day-long offsite brought all of the stakeholders for this sort of into the room. And we broke up into breakout groups. And each group was supposed to come up with sort of an elevator pitch, a vision statement for this effort at Comcast. And Nooper and I were on one of these little breakout groups together, and the other three groups spoke first. And it was really interesting because every other group's vision was some form, some flavor of let's make the policies better and then let's enforce them better. That was essentially the only stick, the only the only tool in their toolbox that they thought they had. And when they got to ours, we focused on culture change and behavior change and adoption, and that was more our vision. And of course, that's the one that sort of, we could sell better, and we won the day, and we were able to sort of get permission to implement this across Comcast. But what happens when you focus only on policy enforcement is you get a sort of very negative pattern that happens. A few things sort of happen. In the best of cases, you get teams that understand the policies. The policies are really well crafted and fit their context exactly, and they implement them, the spirit as well as the letter of them, and it accomplishes the goal. But that's not the common outcome. The most common outcome is one of these other alternatives. They realize that the policies are outdated and they don't actually match the current thinking about security, and so they either ignore them, and sometimes they get away with ignoring them forever. Sometimes they get caught when they ignore them, and they will get a checklist of things they just absolutely have to comply with, or they're toast. And so sometimes they'll do a checklist compliance activity, and that's probably getting you some benefit, but they're not really taking it to heart. And then if you push too hard on development teams there, developers can hang their shingle out and in minutes they'll have a dozen job offers, and so they'll leave if you push too hard on that. Another thing that happens is you get this empowerment taken away from them. You take away their agency, and so they stop thinking of security as their problem. Well, security is gonna go check it and enforce all this policy stuff. I'm gonna just do the best I can, but I'm not going to try real hard to understand what that means, because we got this other group that really owns that aspect. And so you really shift the burden, and you never get ownership. And that's the key in my mind to really making this work. So that's why I'm not a big fan of policy enforcement. So that list of principles is a tool I use when I meet with development teams. I show them this, and they say, "Oh, finally, someone from security gets what we're talking about." And then I have this other tool that I call the pledge. And this took me 9 months of walking around every little security group that exists at Comcast and showing them some version of this pledge and asking them if they can sign up for this, if they can support this. And, in the end, I got maybe, 60, I modified it several times based on their feedback, but I got about 60-70% support on this. And then finally, Nooper said, "Okay, that's what we're doing. So if you want to still be part of the security team going forward," not exactly. She's much better at the judo moves of dealing with security people than I am. And but she basically said, "This is our philosophy, and this is what we're marching towards. So I really need you to support this." And so this is now the pledge that the security team is giving to the development teams every time we need them. We trust you. We trust that you want to do the right thing. We also trust that you are closer to the business context and will make smart trade-off decisions between security and other risks. There's a great example of this at Comcast. If you're a Comcast customer, you may or may not have the X1 video box with the voice interface. So that team that was launched 5-6 years ago at Comcast was told, "Hey, we're starting to see cord cutters. That's going to have a huge impact on our business eventually. And so we want you guys to have permission to solve the business risk of cord cutting, bend that curve, and don't worry about performance and reliability and security at first." And that was a really brave thing to do. And of course, the security people, even to this day at Comcast, a lot of them are not happy about that permission that team was given. But I think that was the right thing to do, that the business risk was greater than the security risk, and they were given permission to sort of address that first. So it's your choice how much of this you do, and it's all based on your context. and other things going on pulling at you. But we are going to help you by providing you information and assistance to make better smart trade-off decisions, as well as actually choose the higher security side. So we pledge to lower the cost to effort side of any investment in developer security tools or practices. When I first started at Comcast, if you wanted to use a static analysis tool in your development cycle, your subgroup inside of Comcast had to go through an evaluation process, pick a tool, and then license it yourself, which is, working with legal and working with purchasing and getting budget and the whole 9 yards. Basically, when we started this effort, I said, we're going to have to globally license all of these tools. We're going to have to own the evaluation process. We're going to not be able to pick just one, because not one tool will work in every context. We're going to have a suite of them, and we're going to support them and make them super simple for development teams to just say, I want to use that tool. Great. You don't have to go through a purchasing cycle. You can use it. So lowering the cost to effort side of any investment in security tools and practices. And we also promise that we're going to assist you twice as much with these preventative things as we beg for your assistance reacting to security incidents. And prior to this, the only time a development team usually had contact with a security person, or the most common time, was when there was a big vulnerability or even an actual incident that was out there. We understand that we are no longer gatekeepers, and our role now is that of toolsmiths and advisors. And these last two bullets, the 2X and the no longer gatekeepers one, were the toughest ones to get over on the security group. In fact, I originally had the assist was 10X, not 2X, and they talked me down to 2X. So that's where we are with that. This is incredibly powerful. When you sit in front of the development team and you show them this and you walk them through this and you talk the way I'm talking right now, they say they really recognize this is completely different than any other interaction we've ever had with security before. I can get on board this. This is what I want my team to do. So, this is all derived from a concept that I call the trust algorithm. And at the heart of the trust algorithm is this thing called the trust formula, which is essentially credibility plus reliability plus empathy all over apparent self-interest. And I've got a blog series on DevSecOpsDays.com. I'm on post 2, about to publish post 3 it'll probably be a 6-part series. So if you want to follow along with that, the link is up here right now. We'll actually post it up at the end again, so you'll get another chance to sort of find it. But if you just go to DevSecOpsDays.com and go to articles, you'll see it there as well. So pretty easy. But a lot of what I just talked about is derived from the concepts of this trust algorithm. So it's sort of foundational to what I'm thinking. Okay, so 3-part framework. First part is win the hearts and minds of developers. Second part is make it easier for development teams to know what the right thing is and easy for them to do it. So I have this thing called a DevSecOps self-assessment, and it is essentially a facilitated self-assessment. I sit down with a team with this table of about 30 different practices organized into a list of disciplines. This is a subset of all the disciplines that's on the screen right here, and we color code them. We ask the team, "Are you doing this already?" And this table is going to be custom designed for every organization, because in order for you to go down and sit with a development team and say, are you getting the training you need? You need to have a training program available to them that's easy for them to just sign up for, and they're motivated and rewarded to sign up for it. So we had to create this belt program for training at Comcast. Yellow Belt was sort of the easiest 90 minutes of videos you watch, and we custom designed it, and the videos are all the way from our president on down to our CISO, on down to a handful of development teams that sort of are leading the way for us. And now we have a green belt that's launched, and that's a lot more involved, a lot more training involved. We don't have the brown belt launched yet, and the black belt launched yet. So those are grayed out. We intend to launch those, and so we've got them sort of identified here, but development teams can't color code that to green or amber or red right now. So we walk through the cells of this table and we color code every cell. And at the end, we ask the development team to pick one, maybe two, maybe three amber or red cells they want to try to turn green in the next quarter. And that becomes our mission. My staff, my team then takes that list, that short list of 2 or 3 things that the teams want to do, that they've committed to do, that they've set as goals for themselves, and we do everything we can to help them do that. If they want to, have static or IaaS or software composition analysis tools integrated into their pipeline, great. We immediately set up a meeting with them, with our tech folks, to go in and understand what the technology they're using in their pipeline is. We have a suite of recipes that we, know how to plug into every, pretty much every technology that's out there. And if we don't, we'll create it for them. And then we sit down and we get access to their repository where they store the configuration, and we will modify their pipeline configuration, and we'll submit a pull request to them so that all they have to do is accept the pull request, and then it's implemented into their pipeline. We make it as easy as possible for them to accomplish their goals by essentially helping them every step of the way. Now, of course, that's really the easy work, the stuff that I just described. The hard work is getting them to change their working agreements so they know they become aware of findings from these tools immediately as part of the pipeline. That's not too hard, but you have to make some decisions about that. Then, what's the policy for my team? What's the working agreements inside of my team for when we'll consider a story done or a feature done or a sprint done? Is it okay if the scan from this static analysis tool set to OWASP top 10 policy setting, is it okay to still ship with that? Can we consider the sprint done? Yes or no? And so the team is going to have to adopt these working agreements and then evolve them over time as they get more and more mature. And the row for the tools that I've just been talking about in this table here sort of walks them through this ever increasing level of maturity. And I point to this first one here, this stop the bleeding practice. So when you run some of these tools for the first time on a large code base, you sometimes find thousands of things, hundreds. You're happy when it's no more than hundreds, and you're super happy when it's a couple dozen. But frequently you find thousands of things. Now, if you were to give that list to if the development team were to run this tool and they were to see that list, they would get overwhelmed. So we tell them that when that happens, ignore all those legacy findings of the tool. Ignore them. That's what we tell them. Don't pay attention to them for now. Instead, decide on what you want your target level of sophistication, maturity to be. Let's say we want to go to OWASP top 10 level, or we want to go to SANS top 25 level, or PCI 3.2 level, or something like that. You decide what that is, and you turn that on, but only for new code. So basically, the pipeline will get stopped. The pipeline will get interrupted. Your CI/CD pipeline, your development pipeline, your dev cycle will get interrupted if any of the new code that you wrote today violates that sort of policy you're trying to eventually get to for everything. The reason this is so powerful, and the reason I have teams start with this fairly simple step, is that it allows them to work through all of the working agreement changes that are necessary for them to actually truly adopt this tool into their core practice and really use it. Frequently what you have is you have a security specialist group run these scanners, give a list to development who either ignores them or does something with them, and then the tool is sort of forgotten about for a long time. We want them to be running it every time they make a commit, or at least every time they reach sort of a sprint boundary or some other cadence boundary. And when that happens, you're going to get a lot more feedback a lot more often, and we want them to have working agreements that essentially describe how they deal with that feedback, what they do with that feedback. And we want it to be easy for them to ramp up. So the idea here is that the table is not designed for the maximum security soonest. The table is designed for the most gradual on-ramp for development teams. Okay, so three-part framework for getting developers to adopt this stuff. Part one was principles. Part two was this knowing what the right thing is with this table that they color code. Part three is getting management involved to both, have transparency about what the current state of things are, but also as a mechanism to help set goals and make it more of a priority for the team to focus on security as opposed to just shipping new features that their team has. So if management sees sort of the risk and understands it and sees sort of what the focus is in terms of improvement, they can help set those goals and encourage development teams to use them. So I'm actually not very happy with this mock-up of a visualization for this. I actually have a new mock-up in place that I haven't quite got to the point where I'm ready to show yet. But I'm working on it. But anyway, this is the visualization that I'm planning to use to talk to execs at Comcast. For every cell in this table, it corresponds with a cell in this table. So this upper left cell is the yellow belt cell, and so this is the yellow belt cell. And the green bar represents how many of the teams in the org, and the org can be the whole org, which is hundreds of teams at Comcast. Or it can be some subset, like one division, which might be dozens of teams. Or it could even be a department that might only have 3 or 4 teams. But anyway, you can render this visualization at any part in the org tree. And when you do, the green bar will represent the number of teams that are green for that particular cell. And the amber will represent the number of teams that are amber for that particular cell. And then the plus 6% is how much better the green is from the last time we run this, maybe a quarter ago, maybe a year ago. And then you can also add a goal line, and I don't show that here, but in the new version, I have a goal line. And we can say that we want to get to 100% green for yellow belt by the end of 2018, and that be the goal. And then the teams the management will trickle that down to the divisions and then to the departments and then to the teams so that they can understand that that's sort of the goal. And then, of course, every team should adopt that goal and all that. So we talked a little bit about the framework and making things easier. We want to make tools easier as well. And one of the things I sort of focus on with tools is I want development teams to think of tools, security tools, as just another testing suite, like their unit or acceptance or functional or integration or whatever testing suites they have. I tend to think that it fits better as a parallel to sort of integration tests or functional tests, maybe acceptance tests, although not usually. But basically you install it in your pipeline and you absorb feedback from it essentially the same way you would absorb feedback from your integration tests. If your integration tests fail, the product doesn't ship. And so that's essentially what we're trying to get. Now, with security testing tools, you can set the policy dial down really low, just stop the bleeding mode, or you can turn it up to OS Top 10 mode, or you can even just set the policy dial to a single CWE. So you can slowly turn up the dial. So in security testing tools, what I'm saying is it should stop the pipeline, interrupt the pipeline, exactly like your your integration test or your functional test you would, with that caveat that you get to tune the dial on it for this. I also use this continuum and I overlay over the top of it my DevSecOps tools landscape. And I'm going to start talking about a category of tools that's, by the industry analysts, call it software composition analysis. The vendors sometimes call this open source security. And I've heard a few other terms used for this. But basically what it does is it identifies the third-party dependencies in your product. And the interesting thing is that, 80, 90+% of products nowadays are actually made up of these dependencies, and you're only writing 10, 20% of the code. So it's really important that you look for publicly reported vulnerabilities against these dependencies and that you upgrade to the latest version. So these tools also check the license policy. They also tell you what version you need to upgrade to get away from the vulnerability typically, or if there's no upgrade available, in which case you might need to mitigate the risk yourself. They run really fast because they're not doing a whole heck of a lot. They're essentially using a manifest in your source code repository or fingerprinting the dependency folder or something like that. When you configure them, you tell them. And they're quickly identifying the dependency, the version of the dependency, and then they're just looking up in a database. You know, the NVD is sort of the national public database of publicly reported vulnerabilities. There's a lot of other sub databases out there, and WhiteSource is the sponsor of this talk, and it's one of the tools we use heavily at Comcast. And you know, they have a myriad of sources they look at, not just NVD. They run really fast, and I say they're the best bang for the buck, mostly because the bad guys, they recognize that 80 to 90% of your product is made up of these dependencies, and only 10 to 20% is made up of the code you write. Plus, if they attack the dependency that's used by 10,000 products, then they'll have accomplished a lot more. And so the bad guys focus more in this area as well. And so I really encourage development teams that if you're gonna adopt a tool, if you're only gonna adopt one, if you don't only have the cycles to adopt one tool, software composition analysis is the tool you want to adopt. And even when you're gonna adopt more, this is the place to start because it gives you the most value the soonest. Static analysis tools are a very common tool, been around a long time. These tools are essentially programs that look at your source code. So they analyze your source code. They're looking for data control, flow control problems. They follow this pattern called source sanitize sync. They're looking for data that comes from dangerous sources, goes through, doesn't go through an approved sanitizer and goes out to a dangerous sink. They sometimes take a long time to run, but they're very context sensitive. Sometimes they can even suggest where you need to make a change that will fix a dozen or so vulnerabilities. They are prone to false positives though, because they don't actually run the code, and so they can't like go through all the loops. They can't analyze every if branch necessarily. So they sort of approximate the data control and flow control, and that approximation leads to false positives. This is very frustrating to developers because you know, if they spend a half an hour to 3 hours to 3 days trying to find the source of a particular finding, then you know, and it turns out there is no problem, then they feel like they wasted their time. And the psychological burden of this is much greater than the actual time burden. Even tools that get 70 to 80% true positive rates, right? They still are very frustrated by that 20 to 30% of false positive rate. So, and that's typically about the best that these tools do is in that sort of category. There's another category of tools called IAST, and this is relatively new and immature. It's sort of just getting started. It's actually targeting the same goal as static analysis tools. It's doing source sanitized sync analysis, but it's not approximating the data flow and control flow. It's actually just looking at what's actually happening in a running system. So it instruments your running system, and then you run a test suite, or you put, you know, production traffic through it, or you just have manual testers exercise it, and it'll start to figure out the paths the data flows through your product. And you don't actually have to attack it in these test suites. You don't have to try to come up with attack code. It just is looking for the data flow, and then it can see, well, this data came from a dangerous source. It didn't go through an approved sanitizer, but it went out to a dangerous sink. So we're going to flag that as vulnerability. Very, very low false positive rate. They run super fast because essentially when your test suite is done running, then the tool's results are essentially there. It does slow down your test suite running slightly, maybe on the order of 10%. It's sort of what I hear and what I see. But even so, it's very painless for developers to do. So I recommend IAST over SAST now. However, you know, not every team can adopt an IAST tool. Not every team has a robust test suite that they can use. Not every team is using a technology that's conducive to instrumentation. So Java and .NET and Python and Ruby and Node.js are sort of that's it. If you're not in one of those 5 technologies, I don't think you can find an IAST tool right now. Those are the only technologies that they are. So if you're doing Golang or C, C++, you can't use an IAST tool. So I basically recommend teams do one or the other of these. And so I've created this new category that the industry analysts haven't adopted yet. I'm going to try to convince them to, called primary code analysis, or PCA, which is essentially pulling these two together. So there's more to this landscape, but I've got it grayed out because I don't really have a lot of deep stuff to say about it today. So this is the whole landscape for developers, but we really focus on these three right now. And really, it's two big buckets that we focus on with development teams. Recommendations for rolling out these tools: integrate them into the pipeline, and they run fast. So this is criteria that the tool has to meet in order for you to pick it and to integrate it. A lot of these tools you can parallelize, so you run a test suite at the same time, like an integration test suite, at the same time you're running one of these tools. And so you don't actually need to serialize them. In some cases, you do need to serialize them. So, for instance, the static tools will run on the source code, and you don't even have to have the product built to run them. So you might do that first, and then later, after the product's built, you run a tool that requires a runtime series. So there's some series in your pipeline as well. Another pattern that I see more and more now, and this is actually very common for the tools that I would have previously put in the lipstick on a pig bucket. Their tool takes hours or days to run. You're not going to be able to run that in a build pipeline, or a DevOps pipeline, I should say. So the way some of these tool vendors that are actually trying to actually adapt to true DevSecOps is they added what's called an incremental mode. So you run the baseline nightly or weekly or whatever, and it is gonna, in the pipeline, it's only gonna actually look for things that are deltas from that baseline, and that can actually run pretty fast in some cases. There's a couple of tool vendors there's one tool vendor that I think actually does this really well, and I'm ready to take the lipstick on a pig label off of them and sort of put them in the primary true DevSecOps tool category. You can ask me about that offline. I don't want to talk about tools here other than our sponsor, WhiteSource. And then, there's some tools that you're going to run out of the pipeline asynchronously. This baseline run, for instance, or some manually oriented process. Maybe you have a tool that's a combination tool service. There's a couple of vendors that are out there like that. You're not going to be able to run this in the pipeline. So run it outside of the pipeline, run it out of band, and use the feedback from that for the next development cycle. So that you can still integrate them in the concept. I would not label any of the tools that only work in this mode as true DevSecOps tools, even if they're marketed that way. Notifications, they have to be able to send them into Slack or email or a report or a dashboard or whatever. That the tool should support notifications in a number of different ways. They should support interrupting the pipeline the way the team wants to do that. Sometimes you literally fail the build, so it stops and a flag goes red and the team gets notified that the build broke and then you have to go fix it. But more common nowadays is for these tests to all run, and you don't break the build when there's one failure. You basically, accumulate this list of problems. And then when you get to the point where somebody's supposed to manually click the merge button, they look at that report, that result. And the merge button might even be grayed out if it's not a perfectly clean bill of health. If it's grayed out, there's usually the ability to override it and merge it anyway. Maybe you're going to accept the risk of not having a clean scan. But most of the time, we're encouraging teams to set the policy dial low enough at first that they don't behave that way, that they don't have a lot of situations where they accept the risk, that they always trust that the tool, if it says that it's not suitable for production, then you fix it before you move it along into the pipeline. And do that by making the dial be very low at first and turning it up. Also, you'll have different sort of dial settings, policy settings for different environments. And your tools should support this model. A lot of this is sometimes just command line parameters when you write the script to go in your build environment. And so sometimes the tool doesn't have a sort of GUI plugin for you, but they usually have a way for you to do this. But it's one of the things you should make sure you check before you pick a tool in the DevSecOps, in a true DevSecOps environment. Other recommendations, as I said, start with software composition analysis. Next, implement the primary code analysis bucket, IAST or SAST. And I favor IAST as a starting point because it's got lower false positives, but it won't run everywhere. So you do that. Now, I don't just recommend you necessarily only run one of these tools. You can run multiple of them as well, but I recommend you start with one in each of these two buckets at first. Embed in the pipeline and treat like an additional test suite. For Greenfield, you know, if you're just starting out, or if the initial run comes back and says there's only a few things, then turn the checkers all the way up, turn the policy dial all the way up to the maximum, and then just not let anything get through the pipeline without getting a clean bill of health from your tools. However, for legacy code bases with thousands of findings, you want to focus developers on the code that they're most interested in, which is the code they wrote today. So implement a stop the bleeding setting for the policy, and then slowly come up with a plan to address all the old critical and high issues. That's an archaeology project, so it's going to take you a while to necessarily get through that. But set a goal for that and try to achieve that. So we're back where we started on this picture here, and basically, you know, giving you advice that just putting the DevOps label on a traditional tool or a traditional concept isn't going to work. It's fundamentally a different way of operating with much more rapid push to production. And so your tools and your process definitions all need to accommodate that. And you have to sort of, you know, be a little bit skeptical about things labeled DevSecOps out there. They aren't all truly, you know, conducive to actually being fitting in a DevOps environment. So before we move on to questions, I wanted to thank Security Boulevard for hosting today, and especially WhiteSource for sponsoring. And I think Gabby's going to come on here and say a few words about.
Thanks, Larry. That was great. And thank you to everyone who has attended the webinar so far. Now, as Larry had discussed the need to automate security throughout the CI/CD pipeline in his presentation, we here at WhiteSource help software development teams to harness the power of open source without increasing their security risks. Basically, we automate the entire process of open source components selection, approval, as well as the detection and remediation of open source security vulnerabilities in your applications. Now, we do that by integrating into your repositories, build tools, package managers, and CI servers and detect all open source components in real time. You see, we believe that automation is the key. Using our solution, we can enable companies to automatically enforce their security, quality, and license compliance policies to block vulnerable or problematic components, and more importantly, to gain full control and visibility over their open source usage. We are trusted by Microsoft, IBM, and more than 400 customers worldwide. So if you want to try out our solution, feel free to check us out on whitesourcesoftware.com and sign up today for a free trial. Larry, back to you.
Thanks, Gabby, and I would mirror everything you just said there about your tool, having used it extensively now at this point. So a couple more, you know, things that you can do coming out of this webinar. As I mentioned earlier, I was going to post the link to the Trust Algorithm blog post series. That's the first one in it, and I'd love for you to follow along and comment on there. Most of the comments around it are actually located on LinkedIn. So if you connect with me on LinkedIn, I'll actually post links every time I come out with a new post in that series, or even after that series is over and I move on to the next thing. I'd love for you to connect with me. And I think now we're going to move on to questions.
Yeah, great.
Do we have questions?
Yes, we're about 6 minutes to the top of the hour, so we have time for maybe one or two questions. So we'll go ahead and dive right on into it. The first question is from Scott, who asks, do you find the need for manual ad hoc security testing remaining the same when automated tooling is utilized in the pipeline?
Absolutely not. You know, the manual security testing I think should be done by professionals, pen testers, on a cadence. But the cadence could be annual or quarterly. I think it's just sort of another way to get feedback. But I don't see it being a primary tool anymore. Think about this: if the very best pen testing groups using the very best tools are only going to find about 20 to 30% max of the latent vulnerabilities in your product, and typical groups, it's down around 5% or less. So you're already shipping into production with 95% or 80% or 70% of the vulnerabilities still in there. That sort of gating way of thinking about those manual practices, is not going to get you much better than that. It's still valuable to catch that 5% or 20% or 30%, but it's not going to get you all the way there. What you really need to do is you really need to have a lot of feedback channels. One of them is this professional security assessors that I just described, this professional pen testers, but another one is your tools. And the frequency that you can get feedback from a tool is going to lead to a much more rapid progress on you getting that list down of latent vulnerabilities down in your product down into low ranges.
Okay, great. Next question. You say software composition analysis or open source software security is the best bang for the buck. We don't do open source at our company. Is it still the best bang for the buck?
Yeah, so there's that term, both of those terms, software composition analysis and open source security, and I've heard others tried to be used on this category of tools. It's very confusing because it doesn't indicate exactly what it's really doing. If you were to tell me, you said we don't do open source, and I think what you're probably thinking is that we don't contribute to open source. We don't have products that we've developed in-house that we put out as open source. But I would venture to say that almost no software that's built today is not built without some open source or other third-party components. And the majority of them that I run into now are up in the 80, 90, 95% of the actual shipping binary is actually made up of these third-party dependencies, and only 20, 10, 5% is made up of the code that you wrote. So I would ask yourself, to sort of think about that and ask your developers, are you actually using open source dependencies? Are you using libraries like the one that got Equifax? Apache Struts too. They didn't upgrade to the version that got rid of the vulnerability. If Equifax doesn't have any products out there in the open source space that I know of, but they're consuming open source products left and right. So I think it's a little bit of a problem with the name, but I suspect you probably do have this concern inside of your organization.
Okay, great. Unfortunately, I think that's all the time that we have for our questions. We're about a minute and a half to the top of the hour. Please know that if you submitted a question and we didn't get to it, Larry will be receiving a copy of all of the questions. And so I'm sure that he or somebody over at WhiteSource will be more than happy to get back in touch with you and get your questions answered. Also, you can connect with him on LinkedIn. Larry, I don't know if you want to put that slide back up so people can get your contact information if necessary. Also want to remind the audience that today's presentation has been recorded. So if you missed any or all of it, you will be receiving a link to the event very shortly, and you'll be able to access it on demand. The webinar will also be available on the Security Boulevard website, and we have lots and lots of other webinars listed on that site. If you are interested in learning more, please take a look, and hopefully there'll be one or two that pique your interest. Larry Maccherone, thank you very much for your time today. It was a great presentation, and thank you also, Gabrielle, for chiming in and giving us some more information about WhiteSource. Thank you both, and thank you to the audience for attending today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thank you, everybody.